So welcome to the Build Scalable Web Apps with .NET and Azure. My name's Matt Soucoup. I'm a Principal Cloud Advocate. So we're going to talk about scalable web apps today. Really, what we're going to be talking about is taking a older type of web app and moving it to Azure and making sure it is good and ready to go. That it's available everywhere, worldwide, it's fast, it's robust, it's obviously scalable, everything. So what we're going to start with is this. A web browser hitting an on-prem MVC application. So I wanted to go with, I'm not going to call it an older app, but an application that we might find more in an enterprise setting. And then hitting right now a cloud Azure SQL database. So the SQL is already up in Azure. We could have it on-prem as well, but I put it up in Azure for now just to help with the demo and help speed things along. And then what we're going to go with then, everything's on-prem. And the problem with everything being on-prem is that you have to take care of the infrastructure yourself. And that kind of leads to things not being super easy to scale. Now, if you're all on-prem and you're just working in a company and everything's in one building, that's cool. I mean, scaling really probably isn't that big of a deal. But if you have multiple, if your company's spread out over the world, or if you're working with a consumer application, scaling might be an issue. And then resiliency. If something goes down, you're going to want to make sure that your customers or the other employees in the company don't know about it. You want it to keep on going. And really, what I like to think of resiliency is success in the face of success. That like the day after Thanksgiving and everything is super busy and hitting your web app and it goes down because it's so busy, you want to make sure it actually stays up and keep on going. So success in the face of success and being robust. So what do we want to get to? We want it to be scalable for our web app when we move it to Azure. We want it to be robust. We want it to get it kind of microservice-y. Now, I'm not going to go through a whole microservice talk where we talk about putting everything in containers and talk about multiple languages and having a database for each microservice. I'm just going to use an Azure function here, but it is kind of splitting things off into their own little world. Secure. A lot of times when we have things on-prem, at least back in when I used to work in the state of Wisconsin at the Department of Natural Resources, we were not, I should be quiet about this, but we weren't super secure about when we put things up on our servers, meaning I could get to it. Or the connection, there were a lot of connection strings that weren't, they were in the app settings. And when a connection string isn't private, it's just waiting to be used everywhere. And so all of a sudden that database is being hit by everybody. We want it to be fast. We want it to get to where we're fast. We want to have server power behind it. Kind of goes hand in hand with scalable. And we want it to be low maintenance. I don't want to have to be dealing with a server that goes down. I don't want to be having to patch a server. I don't want to have my IT have to worry about that altogether. We want to offload that on somebody else. And that's what moving to the cloud, a lot of that is all about. So here's what we want to get to. Here's how we want to scale this up. Web browser. We're going to go through an Azure front door. Now the front door is kind of like a load balancer, and that's what we're going to use it as today. A load balancer / resiliency gateway, essentially. It can do a whole lot more, and I'll explain what it can all do when we get there. And then this is our web app itself. So our request goes through the front door, and the front door takes care of our web app. And what's nice, then, if we have multiple web apps, geo-redundant, the front door can take care of routing it to the closest one that the request came from. Data, both Redis cache and our SQL Azure. This next one is neat in that we can have app config, Azure app config, which is like our app settings, but in one spot. That way, if we have multiple things, our things being in this case multiple web apps, or like Azure Functions, they can all hit app settings from one spot, and Azure Key Vault, where we can put our secrets into, our connection strings that we don't want to leak anywhere. And then we can get our connection strings through Azure App Settings. So now we're sharing everything from one spot. Protect everything by logging in through either Azure Active Directory or Azure AD B2C, business to consumer, depending on whether you have a consumer app or just an internal Active Directory app. And you can even set it up so it's business to business if you are building an app that way. Today we'll take a look at business to consumer, B2C, mainly because that's the easiest one to set up in a demo. Then we're going to get into the microservice E route and enable async communication. We're going to have the user hit a button. Essentially what we're going to be showing off is a consumer application where the person can go in and click and buy a ticket to a concert. That ticket then is going to be put into an Azure queue. An Azure function then is going to kick off and generate an image of that ticket, put that into blob storage, and then eventually, once that image is generated, the application is going to be able to view it again. And all of that is going to be managed by what we call managed identity. And so what that means is from the web app to the Azure SQL or to app config, it's all going to trust each other behind Azure. So I'm not going to have to take care of saying, hey, you trust it. It's going to trust itself. Now, actually, I'm going to have a couple connection strings in there just so I can show you how Key Vault works. But I will show you how the managed identity works so we can show how just Azure lets you trust other things and set up role-based access control between everything. Sounds tough, right? There's a lot in there. We're going from web app, on-prem web application, Azure SQL to this. But we'll take care of it. And here's what we're going to do. Web app, move it to Azure, and we're going to demystify all those services along the way, and so you can find out what you can do and what they're all about. Because a lot of things I find in my job is that they're hard to know about. So if you don't know what you don't know, you can't use it. And then even when you find out about them, it's like, I'm not sure what I would use this for. So that's what I want to get across in this talk as well, is so that you know what Azure Front Door is. So it's a option if you decide if it's correct or not for you to use. A lot of them are self-evident, like Azure SQL. Makes sense. That's a relational database. But some of them, Key Vault. Well, now let's use that. See how that can make sense. All right, so the first demo I want to take a peek at is what we currently have today. And that is going to be in Visual Studio. So what we have is just an MVC application. We have controllers. I'll open one up. Let's just call it the concert controller. And we'll grab the index. And it's just returning from a entity framework, which is hitting the Azure SQL, just getting stuff out of it. There's really not much to this at all. It's pretty straightforward. And what it's doing here in the startup is that it's right now going out and getting a bunch of connection strings from app settings, which happen to all be blank right now except for Azure, the SQL database, and then newing up everything if it's available and putting it into the services. So something that you all probably have dealt with if you've created an MVC application before. Nothing really crazy going on here. So I'll start the app up. We can take a peek at what it looks like. And hopefully it runs relatively quickly. I'm using an old Surface 2 notebook because my manager says supply chain. We can't get a new one. So, all right, here we go. Okay, first thing. One of the issues that we have right away is when we're dealing with Azure SQL is that it has a nice firewall in place and it doesn't let things go through. So client IP of 131.107, this one, we're not allowed to do it right away. So what I have to go through then is pick my Azure SQL out, the server, and then open up a firewall port for it. So I'm necessarily creating a security risk. So if I go down to network, let it spin, and then I'll add my client address, save it. So it updated the firewall rules for it. I'll give it a restart. So not super great of the first thing, and it's already saying that it can't do it again because it's, excuse me? Oh, was it? All right. So 131, 107, yeah, it was a different address. All right. Let's put that in there. Let's see what it was, which is odd. All right, thank you for catching that. All right, so now let's see how this runs. Here we go. Happier, so it's just going to be as cloud concerts. We're going to be able to view the upcoming concerts, and so hopefully this hits. It does, and we can just see this is old, so we can have like cold plays out there. So I'm just showing that it's a older application, and I can go through, add it to the cart, and go through. It's a simple e-commerce application, so hopefully it's familiar to everybody. And if I go in and want to see tickets, I'm not logged in yet. No authentication scheme was supplied. We'll add that in, so it starts working eventually. All right, so that's what we're running with right now. All right, so we're at Azure SQL, but an on-prem web, and we have a firewall port open. We have two firewall ports open because somehow Visual Studio is running on a different one than the web portal. All right, so what we want to take care of is the infrastructure. We're not super secure because we have a connection string in the app settings to get there, which has our Azure SQL password in it as well, our database password. And are we scalable? Well, not really, because we're going to deploy to on-prem. We're not really robust, at least if we just have one. So if we just have like this old web server sitting underneath our desk, not really. So let's do this. Let's deploy it to an Azure Web App Service. Let's do Key Vault, and let's do Managed ID. Let's secure this thing up and make it a little more robust. So why app service? It's fully managed. It's a platform as a service. So maintenance and patching taken care of for you. Secure, right? It's going to be, Microsoft is going to take care of it. And it's going to be up most of the time. It's going to have load balancing in it as well. Multi-language support, when I say language, development languages. So you could be doing Python, you could be doing .NET. It's going to support. And also has container supported. So if you're doing container development, putting things into Docker, you can push that up to it as well. So it doesn't, I'm not doing that right here, but if you wanted to, totally cool. And you can deploy it to different Azure data centers. So you could have one East US, West US, or Central France, South America. Wherever the Azure data centers are, you can push it out there. And when we put it behind a load balancer, the front door, when one goes down, it'll automatically route to another one. And there's nice Visual Studio integration. One that we're probably familiar with is the right-click publish, but there's other things too where we actually can attach to it and debug in production. Not super great, slow, but it works. There's Visual Studio integration. So why Key Vault? It's a centralized secret management store. It is secure, and it has Azure role-based access control behind it, which means I can have access to it, but a coworker can have access to Key Vault itself. So it keeps secrets just where we need to have them. Also has secrets just for web applications. So we can just have one web application have it, and other web applications who shouldn't have access to these various connection strings that are in there or whatnot won't have to it. And we can version secrets. So if I'm sitting at a coffee shop or something and somebody looks over my shoulder and happens to catch what that secret is, whatever it happens to be, I can cycle the key and now it's gone. It's not going to work anymore. But the way I access Key Vault is going to be exactly the same because it's running on AD, Active Directory. And it doesn't get in your way. So it's not any more difficult other than a couple lines of code when you set it up to get at it. So essentially, forget all about those secrets. The only password that's secure is a password that you don't know. That's what Key Vault happens to give you. So let's do this. Let's get Azure App Service involved. And let's also get Key Vault involved as well. And so what I'm going to do, first off, is close all these for now, and then add in the NuGets for Key Vault. So Key Vault has its own special NuGet packages, which I have written down right here because I won't remember it otherwise. And just have to add it in. All right, should go through okay. And while it's adding, one thing I do want to show you is what Key Vault looks like in Azure. All right, so here it is. And one thing that you can do, you can put in keys, secrets, and certificates. And right now I don't have anything in here. But what we're going to be doing is secrets. And so the first secret I want to put in here is the SQL Server connection string. So I'm going to go back to my app settings. And I'm going to grab this out. And I'm going to pop it into Key Vault itself. So what I'm just going to do, I'm just going to call it SQL connection, give it a name, enter the value, and I can see what it looks like if I wanted to, and then create it. And so what's nice about it, when it's here, if I wanted to, has the current version, and if I wanted to create a new version of it, I could disable this and then create a brand new version of it, and it'd be the same way to get at it, just by hitting new version here. And it should show me right here, the secret identifier, this URL is all I'm going to be accessing it by is /secrets/SQL connection to get at it. All right, so the next thing I want to do is actually give myself access to this Key Vault. And so it already has happened just because I own it. And so I can get access to the permissions, key permissions, secret permissions, and certificates because I'm the owner. But you can specify only what you need. So least privilege here. All right, so that's what Key Vault looks like. So let's add things in here. All right, so one thing I want to do then is create a Key Vault version into the app config or the app settings. And that's going to be the Key Vault URL. Like so. And I have installed it. Looks good here. And then all I have to do then is actually go through and then enable it. So that's going to be in my startup. And then I'm not going to check to see if it's empty or not because I know it's in there, and eventually I'll probably get rid of it. And then all it's going to be is I'm going to new up a key vault client, and then we should be good. Oh. All right, so default Azure credential. And so this is actually kind of cool here. So what's happening is I'm going through and I'm saying, all right, give me a new secret client, whatever the URL is, and I'm just saying whatever my default Azure credential is. So I'm not actually passing a connection string or anything at all. And I'm actually signed in to Visual Studio underneath Azure, right? So it's my Azure account. And so when I pass it up to our Key Vault, it's going to look and see I'm logged in. What we should just showed in the over here underneath the access policies, it's going to look. It's going to see me being logged in, and it's going to let me go and get my secrets as I need them. And so all I need to do then is do my this is going to be equal to client that gets secret like that, and I'll pull out the secret name, which happens to be SQL connection. All right. So now I no longer have the SQL Server connection string in my app. I don't have to, when I deploy it, I don't have to put it in app settings. I run it here. Line 53. Oh, thank you. All right, then when we hit the breakpoint, now everything I'm doing right here is going to take a longer time when I start up. I should make it faster if I can. But now I'm pulling this out of the Key Vault. So now it's in memory only. Did it change my URL? Oh, that's fine. So what I'm going to do is deploy it. And so I already have a web app created. Actually, and let's deploy to it. And so this is something you've probably seen already before, and it's one of the things that are built in to a Visual Studio that has a nice obviously when we're in production we're going to want to have some kind of CI/CD to it, but when we're doing things like this I can just go ahead and publish. All right, shouldn't take too long. Publish started, and the only thing I'm going to need to have to update in my app settings is the Key Vault. All right. All right, we published Updating the app settings. Got that done. What I'm going to do is just restart it. And the restart takes a little bit, and so what we'll do is we'll just keep on going for a little while. And I wonder why. That is interesting. Now I'm going to have to take a look. Well, it says it's the same, right? That's odd. Anyway. So what we have here, this should have restarted by now. Is up and deployed, and now one thing that you'll notice is that allow Azure services and resources to access the server. Great, and it didn't do it. So I'm going to show off a different one over here that will. And so this one is up and running because we have deployed it. We don't have to worry about firewall rules. It's just up and it's running, which is nice. All right. So what I'm going to do is actually start up the and we'll come back to that. All right, so now we have Azure SQL. We have it deployed out to Azure Web, and now our secrets, our SQL Server secrets are secure. They're in Key Vault. Only I can access them, and the web app should be able to access them. And the web app is not in there yet. So what I'm going to do then is the managed identity portion. Is the app service. I go to identity, and now what I'm going to do is turn this on. And essentially what I'm doing is saying, apps, Active Directory, make this essentially a user. Make this an entity here. And it's going to give me an object ID, a principal ID. And then what I can go do is I can go back to Key Vault, go to Policies, and add it in. And I'm going to just give it to all the secret management, select a principal, pick it up, add it, and save it. So we're up, we're good. And what I'm going to do then is go back, restart my web app to make sure it gets it. All right, and we'll come back to that in a sec. We have the connection strings that are everywhere yet, which is kind of an issue. So let's put it into Azure App Config. And when I say connection strings are everywhere, that we can have, if we do go out and get it, our connection strings, and we have multiple web apps, we're going to have to start putting them in app settings. And we have to go out to app settings everywhere. So we want to change that, right? And so let's put them out in App Config. So why app config? It's a centralized configuration store. Multiple apps, same store, can get at it. Has Key Vault integration to it, which is super nice. We can do feature flags. So we can do things like A/B testing by using app config. And it's secure using managed identity as before. And there's Visual Studio integration as well. All right. So let's see Azure App Config work within our app. So what I can do then is, first thing first, is adding in the NuGet packages. And it is Microsoft Azure appconfig.ASP.NET Core added in. And then what I'm going to do is quickly go out here, accept the terms. All right, we're all good. All right. And then go to app config itself and take a little tour of it. So I already have some things out here, and that's when we get up to Azure AD, we can get it to it, and I don't want to have to retype everything in. But what I can do is I can make a key vault reference to it, and then put in what my key was before for Azure SQL, which was SQL database connection string. So one thing I wanted to note in Key Vault, I can't do colons or anything like that. So it's kind of a pain to get at things. I would have to change things up, as you saw. But I can do things like this through app config with the colons. And then I can pick which key vault I want to use. And then which secret I want to have. And now I'm good to go. So by accessing app config, I can get at my key vault. And what's nice here is that I'm still going to have to use key vault configuration. So I could have access to app config, not the key vault, and I'll still error out. And so if I go to access control, I don't think I have access yet. I don't, so I'm going to add me. To make sure I do, and I'm going to give me data reader. And now I can access, once it's done, app config. All right, here I go. So I am going to go through I'm going to take this out of here, and you see I was using the secret of SQL connection. I don't want that any longer. Instead, I'm going to go into the program and do something like this. I'm going to have to, you know what? Instead of typing, I am going to open up a new one. This guy, so we can just go through and see the end of it. All right, so what I'm going to do here is this part. Is I get the app config URL. So now what I'm doing is I'm just keeping track of the URI of the app config itself. That's all I have in here. And then I'm doing a builder add Azure app config. So now not only am I going to be able to get at app settings, but Azure app config, same way as usual, using my default Azure credentials. So whoever I'm logged into Visual Studio as, if I have access to app config, I can get it. And then also configuring Key Vault along the way. So I can pass in my Azure credentials to Key Vault or to app config, and eventually app config can pass that over to Key Vault, and I can get at everything. And so then if I look at startup, I don't need to have anything Key Vault related in here any longer. When I go down to my SQL connection, right here, I can just use it as normal. So let's see if we are up and running now. If not, I'll just show it on the one. Okay, we are up and running here. So I am going to go back to the one I have set up, and I'm going to show you app config through here. So through the Configuration Explorer, I have the SQL database, which is obviously going through the Key Vault if it would show up. And that shows the Key Vault connection string that I would have to get at. Cool. And let's see, this should work better now because I'm not actually having to, well, what I'm going to do is actually go like this. And I'm going to trust I'm not going to ever be able to run it locally because of the firewall rules. The cool thing to notice is I'm just using configuration.getValue. And because how I set it up in program, it's no different than anything else. Like I was getting it through app settings. And so when I get the configuration string, it's the same as before. Even though I don't have it in app settings any longer. So I'll just run it this way, and we'll see if I get an error or not. Yep, still getting that, which is interesting. All right, so we're making our way. So we have Azure SQL, Azure Web, secure secrets, and we can get at our configuration all in one spot, including the secure secrets. So now I don't care where I have things. I'm just going to go through app config to get it. Whether it's secure, whether it's not, and I can control who has access to app config with role-based access security, and I can control who has access to the secrets through Key Vault. So like I said, I can't get at Key Vault unless I have access to it. App config, it just passes it on. It's just a way to get at things, and if I don't have access to Key Vault, it'll throw me an error. Data access, though, we could do better. We can introduce Redis cache to everything. And doing Redis cache is actually, let me bring up this slide. Why Redis cache? It's an in-memory data store. It's fast and scalable. You can actually set up multiple Redis cache units and get at it around the world if you needed to. Data caching for frequently accessed data. So what we're going to do for Redis cache, what we're going to put in here is our concerts, because we're going to get at our concerts multiple times. So we want that in there. So we just added it to Redis cache right there. And we are also going to, you could do session caching and a Redis cache as well if you needed to. So let's see that be put in and running. So there is a NuGet for Redis cache to make everything work. And that is right here, extensions.caching.redis. And so once you have that installed, and you're going to get at everything the same way as before in the startup, is just going to connection.getValue, Redis cache.connection string to pull that out. And I put the Redis cache connection string in Key Vault, getting that through then app.redis cache in app config. So the same way I'm accessing everything now is going through one spot. It's the same repeatable pattern over and over. So whether I'm developing locally with my local credentials or having it out on Azure, it works the same way. So we're getting a little bit more scalable. And now whether I had multiple web applications, it would work the same way as well. And then to actually show how to do Redis stuff is right here. This is an extension method, and it's add distributed Redis cache. It comes from that NuGet that I showed. And all we're doing is setting the connection string in there. So now, instead of doing the ASP.NET in memory, we're using Redis cache, which is going out to the Azure version of Redis cache, which is Azure Redis cache right here. So we're getting at it via connection string. This one doesn't have the identity, the managed identity. It's in preview right now, but if we had it all set up, we can set up the web app to be able to access it if we wanted to. So that's how you would get around actually doing all the connection strings, is setting up this managed identity and just having like the web app being able to access this right off the bat. But we have the access keys, which let us set up the like a connection string. So that's all there is really to Redis cache itself. You could set up data persistence, cluster size, where you want to have replicated and so on, but we're just doing straight out of the box. And then to get at it, it's going to be in here, I believe. Nope, it's going to be in this one. We get past the distributed cache, SQL or dependency injected, just put it into there. And then when we want to get upcoming concerts, here we go. And so all we're doing here is trying to pull it out of the cache. If it's there, using a key, great. We have it in memory, and then we're just deserializing our concert JSON into a concerts object and letting that go. If it's not in memory, then we're actually pulling it out of SQL Server and then putting it into the cache. So that's generally how you're going to use a caching. First, check if it's in the cache. If it's not, pull it out of persistent memory, SQL Server, and then pop it into the transient memory or the cache. So that's generally your pattern that you're going to be using all the time. And so I would have deployed it, and this is the one that's already deployed, and then upcoming concerts is faster than it was that last time I hit it because it's sitting in cache already. Cool. So now we have cached data added. Everything being configured from one spot, everything's secure, we're using the web. It's a concert app. It's an e-commerce application. We should be able to log in so we can purchase tickets and things. Can't do that yet. So we're going to have to add Azure AD B2C. What's that? This is, anytime you start getting into identity, authentication, authorization, things start to get fun. B2C is actually kind of neat in that it allows you to have your customers bring their own identity. Whether they want to log in via Twitter or Google, Facebook, they can do that. Or any of those providers. Actually, if it goes along with the SAML specification, you can add that in the B2C and do that. Once they sign up for an account, regardless of the identity provider that they use, you're going to get an account within Azure SQL, or not Azure SQL, Azure Active Directory to do it. So they're going to get an object ID. They're going to get essentially a user identification number for that. With that said, then you can set up various rules on your business side to whether you want to allow access to an API or a web app or a mobile app. So it's essentially your identity provider, but B2C allows anybody to log in with their own Twitter or whatnot. So you don't need to just do email password, although you could do that. So let's take a peek at what B2C gives you over in Azure. So B2C kind of can be interesting to set up. So the first thing I'm going to do is I'm just going to go back out to here. I'm going to go into the older one, hit create, and just show you what's involved in this. So you're only going to be doing this one time, and it used to show you this. It still does show you this. So before, you would create new Azure AD B2C tenant, and go out and create the tenant for you, and then you'd have to go back and link that tenant to your Azure sub. you don't need to do that any longer. You just can go through and create the tenant yourself. And so you give it the org name, an initial domain name, which would be .onmicrosoft.com. You can change that if you want, where you want the data center to reside, and which subscription you want and resource group you want it to be in. So let's take a look at one it takes a while to get set up. So I already have one set up here. And so this, though, is just like the shell that's sitting in my current subscription in this tenant. B2C, like I said, resides in a different tenant. All right, so you'll notice right up here it says VS Live Setup, whereas back where all my other things are, it says Microsoft. So it's a completely different thing, completely different tenant, but the only thing that's in this tenant is the Azure AD B2C app. And so what's all in here then is just app registrations, which happens, I already have one in here for the concert app. You can go through and you can look at the users, and I already have one in there because I did sign up already. Actually, I signed up twice when I was going through. And then I can see my name, the principal name, and this object ID is what I was talking about before. That's essentially your unique identifier, your primary key within B2C. And then what's neat is that you have what's called user flows. And so this user flow is you can dictate the B2C how you want the user to go through the flow that they want to sign up as, or edit their profile, or reset their password. And it's with this that you can give it a name to specify how you want them to sign up. Right now I only have email here, but if I had Twitter, what I would do is I would go over to the Twitter Developer Center, create an account there, say, all right, I'm going to have a new sign up. It gives me a key. I go over to Azure, enter the key there, so it kind of like creates the connection. Then Twitter would show up underneath this account. And then two-auth or a multi-factor auth here, if I wanted to have that. And then I can specify what information I wanted to collect from folks while they're going through in the sign-up. City, email address, or whatever. And so I'm specifying the flow that folks would go through. And also I can specify through here if they wanted all right. I could specify things like company branding. And so what this company branding would do, we'll see when I go through and log in, is I can configure which graphics are looking like. So if I had the my upcoming concerts, the Relay Cloud, I could configure it so when they sign in, it'll look like that. So right now when I sign out, it has this look, which is unfortunate because I don't have the sign out set up. But we go back in to this, and I should actually be signed out now. And I go to sign in. It's actually sending me out to B2C and has this generic sign-in screen. I could change that to make it look better through this by uploading things. So this gives me a whole way to go through and set up a login flow. And then eventually will give me a way to set up a way to get permissions through where I pass tokens around and specify the various policies of what I want the tokens to accept or not. All right, we're here through the API permissions is what I can do. That where I can add a permission and then specify in my code that I want to request this permission. So when you go through and you sign up for something that says you want to have this app read your profile, that's what these permissions are all about. Cool. That's what B2C is. So in the code itself, there's the Microsoft.identity.web NuGet packages right here. And so that's what's taking care of everything for you. You go down through here. Where do I have it? And startup. And what you're doing is that all you're doing is pulling out the various B2C constants, adding it in, and telling the middleware to say, all right, I'm going to use B2C. Here's my OIDC, OpenID connection stuff. And once the token is validated, I'm going to say create or update user information. And then go to the definition. And what I'm doing here is I'm going in and actually creating the user via their ID in my database, my SQL Server. That way I can hook tickets up to them. All right, so that's a lot of words for showing something like this. I'm going to enter my email address. And I believe I put my password in as so I signed in, and you can see right here it says VSLive B2C login.com. So it actually shows me out to the B2C application while it's doing this. And it should bring me back over to my app when it's all finished. And so while it's going through and doing that, what I'm going to do is show off the in the SQL database. Where is it? Right here. I'll show that I have my user in here. Oh, it's not even allowing me to log in through here. All right, I do have a user in there through a user's account. I'm logged in. I can go through my upcoming, select a concert, add it to the account, confirm I want to add it, check out, confirm I do want to check out. And way down here, now I have it. It's checked out. It's to me. And it's in the database table, which I can't get to because of firewall issues. But it's there. Cool. Assigned to me. Nobody else could see this if I logged in as somebody else. Which brings us to, we added authentication in. Now we want to do asynchronous tasks. Messaging, essentially. Send something out, let it come back. This is our microservice type things. And so let's add the message queuing to it. And so what that's going to do, the async flow that I want to do is I want to buy a ticket like we just showed. I'm going to pop it into a message queue, a storage queue. And then I'm going to have a queue trigger, an Azure function, pick that image up, or pick that queue up, create an image out of it, pop that into a ticket image blob. And then once it's in that blob, anybody can go and view it. Or not anybody, just me, because I've logged in and I have a key, then do it. So let's actually see how that's going to happen. And actually, let's talk about this. Why Azure Functions? Responds to triggers of various types. And so this is neat. Azure Functions has a lot of stuff built into it that you don't have to worry about. Like, so you can actually call it HTTP triggers, and it just works. You can build a web API off of Azure Functions. Storage queues, like what we're going to show. Something gets hit to a queue, it's automatically going to kick off and be able to process that queue message for you. Cosmos DB writes, hits a Cosmos DB, works. It also has bindings. So what you can do is like a Cosmos DB binding. An input parameter automatically is connected to Cosmos. You can set a filter on it, essentially a where clause, and it's only going to grab those records out as your parameter. So Functions sets up the whole infrastructure for you, so you don't have to manage the like newing up anything. You could, but you don't. And it's all written in .NET or any other language you want to, like Python or even PowerShell. Serverless, which is nice because you can scale it all the way down to 0, which means if it's not being used, you're not paying anything. And it runs on the app service infrastructure. So you get all the nice things about app service, like app services scaling, its robustness, whether you can deploy it around the world, you get all that as well. And like I said, you do have multiple language support, Python, PowerShell, JavaScript, .NET, of course, all built into it. And it has nice Visual Studio support as well. So let's see what the Azure function look like. It's right here. And what I have in it is just an event. So what's being written to when I click that or buy a ticket is an event type and an entity ID, just a primary key, and then this event processor. And so I'll make this a little bit nicer. And so what we're doing is saying, all right, a queue trigger, whenever this queue gets written to, using this connection, it's going to look for something that matches that event. And it's going to pull that in. Once it does, it's going to go through, and if it's a ticket created, event type, it's going to go through then and grab my SQL connection string because I'm going to be writing the SQL. SQL, as far as I know, is not a binding, so I do have to pull it out, and I'm going to be pulling it out of, in this case, the configuration, which hits the key vault, and then going down here to create the image itself. And creating the image is actually kind of neat because I'm using system.drawing to go through and populate everything here. And then finally writing that to blob storage, which is just getting the blob service client and writing it to the ticket container name. So the blob storage client, that's all in Azure SDK as well. It's get blob client, upload it. It's fairly straightforward to use as far as that goes. And then right here, I'm setting the permissions to it. This means the ticket can only be read by me. And then I'm updating the SQL database here to be the ticket is me only. All right, by the ticket ID, and the ticket ID is related to me in the SQL database. So only I can see it. All right. Then, have that all deployed. I'm going to look here in my queue. So now, storage queue. I shouldn't have anything in the storage queue right now. Actually, I might have to go through this way. I see the queue itself, but there's no items in it, which means once I refresh this, I should have a Madonna ticket at the bottom. And I do. So I went through, created the ticket, and everything worked. So what I'm going to do is go through and stop my function so I can see the queue in there, or the queue message. I'm going to go through and buy another ticket. And we'll do Edge FreeRAM because I don't have that one yet. Nothing down there. But when I go here, I should see it in the queue, and I'll just sit there until I kick the function off again. And you can see here it's just sitting down there. And it'll sit there until I kick the function off, and then it'll create the ticket again. All right, so the very last thing we're going to talk about then is doing Azure Front Door. And so this is what it gives us. It gives us CDN, content delivery, caches everything that can be close to the edge, such as images, static stuff that does not change. You can put that at the edge. That way somebody who's accessing from Europe or South America or Asia can get things quicker. We can do traffic management. Again, somebody's accessing from a different part of the world. We can route them to the closest web application that we have set up and can also do failover. So we want to have that as well. And so the US website goes down, we can automatically have them go through and hit another one that we have set up. And so front door can do that. And so that has everything put on for us. CDN, load balancer, worldwide it goes. And the communication on that, if we look at the image from way in the beginning, when everything goes to the front door, after it hits front door, it's going to run on the Azure backbone. It's going to run super fast. So it's not running at internet speed, it's going to run at faster speed to various the web apps that we have on it. And it has a rules engine. So we can say, do this when that fails, or we can actually like block traffic from certain IP addresses or for certain countries if we wanted to. And there's actually a whole lot more that we could do. And there's nothing we have to do in our code to set it up. This is all done on Azure. All right, so let's see how front door is set up. All right, so front door has what's called an origin group. And what I've already have is I have both I have one that's called, I'm not sure if you can see it, Euro. So this VS Live setup web-Euro is located, I think, in Norway somewhere. This one is, the top one is in Eastern US. All right, so depending on where I am, or the load on one, it's going to get routed to whatever one can handle it the best. And we can do things, set up like how it's going to be load balanced, make sure it's okay by the health probes, which we're going to want to check out when I bring one down, and then whether we want to enable session affinity or not. And then we could set up our own domain for it. I don't have any set up because I am routing everything through just whatever front door gives me for the domain, which happens to be this. Oops. So if there was more, I could go through and pick them here. And what I could do then is actually match patterns too. So if a pattern was coming through as /API, I could route it to a totally different Azure app service if I wanted to, but still having it hit the same domain. And redirects traffic using the same origin group. And right here, this enable caching, that's essentially putting the CDN in front of it. And then enable compression is I can, for things that I can compress, it's going to set that up for me as well. So it's just as simple as checking checkboxes to set that all up. All right, so by doing this, I should hit my website. And it came up relatively fast here. If I do, I'm not signed in, so I'm not sure if the sign-in is going to work because I don't think I have that actually set up. So one thing you do need to do, and we have just a bit of time, in B2C is actually set up a authentication, a redirect URL. So I'm going to actually put in a redirect URL of this, this lets Azure B2C know where to redirect to once you do sign in. And so it can be any of these right here. And so what I did, I just added the front door here. So when I do go to sign in, I go to a completely different spot, and I don't have it. All right, which is fine. But anywho, so now I'm behind front door, which is showing me all the concerts. I'm going to take down one of my app services. Eastern US. That's what I should be hitting right now. This web app has stopped. Of course, it doesn't work. It doesn't fail over for me. All right. So, assuming I had it set up correctly, what it would have happened is that it would have pushed over. That's because I have session affinity set up. I'll start this back up. And it's going to take a little bit. All right. So what would happen if I didn't have session affinity set up, which always wants to hit me to the same backend, is that it would automatically have failed over and gone to Norway. All right. So web browser hits front door. Front door decides what application is the closest to you. Web applications should be the same that you have set up, same code deployed. So our MVC application hits B2C to log in. It'd be the same B2C instance. That B2C instance gives you your identity. Your identity then is used to hit Azure SQL or Redis. That way you can get only the things that you want or whatever it brings back if it's not identity based. Then when you hit for asynchronous communication, you can hit Azure queues, storage queues. You could hit, there's things like Azure Event Grid or Service Bus, which are also queuing based or messaging based, which is a little bit more powerful than what Azure storage queues are. In this case, storage queues work great. Azure Functions hooked it right into storage queues, brings it out, pops it into Azure Storage for a blob. The blob can be read by the web app again. It's just an image. And we created an SAS key on that blob, stored it in our database. That way only I could get at my tickets. And then app config and key vault, storing all my secrets in key vault so only certain things can get at them. And then app config, running everything in there through the configuration. And so there's a lot of moving parts, but it's a lot more fail resistant, especially when we start using the messaging queues and messaging. We can start scaling things out more. And with front door, we can do the same thing. So with that said, highly encourage you to take the session survey, take the QR, let me know what you think. We do read these and take action on them. And with that said, so thank you very much. And please feel free to reach out, CodeMill Matt on Twitter or matt.soucoup, first name dot last name at microsoft.com. Thank you very much.
Thank you.